All right, so a couple of questions that people had were, how do I know a molecule's chiral, or information about chirality for carbons? When it's a sp3 carbon, there's only really one rule you need to know in terms of a chiral center, and that it has 4 different groups. And so here we have oxygen, chlorine, hydrogen, and methyl. That's 4 different groups. If you're talking about if the molecule itself is chiral, one other thing needs to apply is that is there a plane of symmetry in the molecule? So when you look at the meso question in your classwork, or when you look at meso, that is a reason why meso compounds don't have are not chiral. A couple of other exceptions is we typically don't look at double bonds as having any chirality per se, except for allenes or cumulated double bonds. So these kinds of structures, and I can make a separate video for that. So these, this is actually 2 double bonds next to each other. The dot just represents that there's a second double bond, it's a double bond and then a second double bond next to it. So that's what dot represents. Okay, so the second question is about enantiomers. So how do I know if something is an enantiomer? You can build it, and if they are non-superimposable, so I'll show you the models in just a second. If they're not superimposable, if they're non-superimposable but mirror images, right? So they have to be mirror images and they're not superimposable, then they're enantiomers. So they must have the same atoms attached. So if you look at what I have drawn, they're mirror images of each other. If the OH is pointed this way, in the mirror it should look like it's pointed right there. And you can rotate your models. So if you make your models, you can rotate them to look at it. And after using your models probably for a semester, maybe a semester and a half, this should be in your head after a while. When you try to do it in your head, I would say for about 95% of students, based on psychology, that this is not something that you are going to be perfect at doing in your head for a while. So actually I have a study that actually shows that students who use model kits actually improve their spatial skills over the course of the 2 semesters dramatically compared to students who do not. But there is about 4 to 5% of students under the age of 25 that take a little while to do the models. And there are some people who probably will have to use the models all the time. Some people do have some issues with visual spatial skills. So that is something I highly recommend. I know it's a huge resistance oftentimes from students to do that. So I strongly recommend that you don't, okay? So I did end up putting priorities on here based on atomic weight. One mistake people want to do is add up all the atoms on the thing attached. So this is the priority here is based on carbon, not carbon with 3 hydrogens. If you had a double bond, it's not based on the atomic weight of the carbon attached to the other carbon. Or if you had an ethyl, it's not the atomic weight plus the other ethyl. It's based on what's attached. And if what's attached is the same, then you go to next. And I'll do a problem like that as another video. Okay, so chlorine has a higher priority. That's like, I think it's 35. Then 6. Yeah, I think it's 35. So it's a higher of the atoms, hydrogen being the lowest. So we can see them as mirror images. So I'm going to use the model. And so you can see that I have this model, and I put green is always going to be my lowest priority atom. It's to my right hand side but flat in front of me, so you can see I have it flat in my hand. And then the hydrogen is coming towards me, the chlorine in the back being my highest priority, red, green being my second priority, blue always is going to be my 3rd priority. So you can see no matter what, I can rotate and align my model. And so this is what you must do using in your assignments. Please make sure you're aligning your model correctly. So again, flat, the stuff on the straight lines, flat in front of you, the red going behind you, the white towards you, okay? And if we look at our enantiomer as the model, again, the green being my lowest priority coming towards me, the hydrogen is going flat to my left-hand side, sorry, the methyl going to my right-hand side, flat in front of me, the hydrogen coming towards me, and the chlorine going back. So if I wanted to figure out my rotation, I would grab the lowest priority, make it kind of into my little bouquet, and I go red, green, blue. So red, then green, then blue is counterclockwise. So this would be S. And if I grab this one, I go red, green, blue, and this is clockwise. So it's going to the right, which is clockwise. So R is to the right. Rectus means to go to the right. That's where the R comes from. S comes from rotation to the left, which has to do with being left-handed. And so back in the day, witches, people who are left-handed were considered witches, and they used to call witches sinister. So that's where that comes from.